Here we have an example for a problem where we're going to calculate the average atomic mass, and we're going to compare it to what's on your periodic table to prove to you that it's not just an average of the two mass numbers. There's multiple ways to attack this problem. I find the easiest way is to set up a table. I have two samples of copper 63 and copper 65, and so I'm going to put both of those here using their mass number as their symbol. The problem gives me more information about their mass, so I'm going to use that number. 62.930 is the mass, and 64.928 is the mass for the copper 65. It would round up to the whole number of 65. Now you're given percents, okay? So percent of the copper 63 is 69.17%, and the 65 is 30.83%. Now, that's all the information out of the problem, so now it's not a word problem anymore. The easiest way to attack this is to convert these out of percent and back to a decimal. If you do that now, you don't have to do it later. So 62.90 is my mass, and I'm going to multiply it by 0.6917 because I've divided by 100 to get rid of the percent. I'm going to do the same for the second value, 928. I just realized there's a 3 there, times 0.3083. Okay, so I'm still making a table. I like to keep them separate. That would be your table format, okay, of your information instead of the word problem. When I do this math, 62.930 times 0.6917, I get 43.528681. And when I multiply 64.928 times 0.3083, I get 20.01730024. Now, recognize that in the problem, right, they've given you 5 significant digits and 4 significant digits. If I round too early and add them, I might get a different answer than if I add them up and then round at the end, which is why I've always said that you need to just wait and add at the end. So I'm going to add these two numbers together, giving me a sum of 63.5459834. Okay? Now, that doesn't match your periodic table because there's less decimal places there. I can only be as specific as in the problem, and I can only use the lower of the values. So this is 5, 5, 4, and 4, so I'm going to use 4. 1, 2, 3, 4. And I'm going to round. Now that 5 makes the 4 a 5. 63.55 is the average atomic mass. And you want to compare that to your periodic table. 63.546. If that's rounded to 4 digits, it's 63.55. Which is what you had. If you look here on the periodic table, they rounded to this digit. The 9 would make the 5 a 6. 63.546 matches your periodic table also.